Assalamualaikum and hi everyone. The topic is thermoelectric transducer. First, let's understand what is thermoelectric effect. The thermoelectric effect is the direct conversion of temperature difference to electric voltage and vice versa. The basic theory is based on the electrical and thermal properties of different metal. When there is temperature difference across metal, vibration of atoms occur and motion of electron is affected, causing difference in potential between two ends. Electrons in hotter end have more thermal energy, thus drift toward cooler end which has lower thermal energy. The drift rate is varies for different metals. So when the two metals are connected together, creating a closed circuit, the current will flow in the circuit. The thermoelectric effect can be explained by the Seebeck effect and also the Peltier effect. The Seebeck effect explains the concept of the EMF produced proportional to the difference in temperature between two junctions. The Seebeck effect actually explains the concept of EMF produced is proportionally to the difference in temperature between two junctions. Refer to this diagram here. There are two different metals, A and B, are used to close the loop with connecting junctions at temperature T1 and T2. Electromotive force has been established in the circuit, causing current to flow. This electromotive force that's produced is found to be proportional to the difference of temperature between two junctions. The effect was explained using solid-state theory, where EMF can be calculated using this equation, where T1 and T2 are junction temperatures and QA and QB are transport constant of two metals. Solving the equation, the EMF is found to be proportional to temperature difference. This is because QA and QB are independent of temperature. Therefore, we can use linear approximation to simplify the equation, becoming this equation. So from this equation, we can see that the electromotive force produced is directly proportional to the difference of temperature at the two junctions. The second effect is the Peltier effect. The Peltier effect refers to the condition when external voltage is applied to the system, which causes the current to flow. Again, we consider a closed loop of two different metal A and metal B. An external voltage is applied to the system, causing current to flow. Because of the different electrothermal transport properties of the metals, one junction will be heated and the other one will be cooled. Using the thermoelectric effect, both Peltier and Seebeck effect, the temperature sensor is designed. Thermocouple is temperature sensor that output voltage. Thermocouple consists of two metals that are connected together. A voltage is developed, which is a function of temperature at the junction. The voltage is generated by a thermal phenomenon called Seebeck effect. There is a voltage sum of two voltage effects, which are the Peltier effect and also Thomson effect. Electromotive force, or EMF, is found to be proportional to temperature. In practical measurement, the thermocouple is connected to the measurement device using a common wire from reference point. See, here is the common wire. So we have a thermocouple, metal A and metal B. To connect to the measuring device, we use common wire C. This configuration is called three-wire thermocouple. However, often the reference point need to be moved to more secure location. The reference point need to be moved further. To do that, an extension wire is used using the same combination wire as in thermocouple. So this is thermocouple. The extension wire is also a combination of A and B. Then we'll be able to move the reference point to more secure location, and then we use common wire to connect to the measurement device. The voltage generated in thermocouple depends on the composition of wire. The wire pairs are manufactured according to National Institute of Standard and Technology. Common thermocouple pair like chromel, which is alloy of nickel and chromium, alumel, alloy of nickel and aluminium, constantan, alloy of nickel and copper. So in this table, we can see that there is a standard wire pair such as copper constantan, chromel constantan, iron constantan, chromel alumel, and etc. Each pair has their own letter and also color code. Different pair will have different operating range, and also the approximation sensitivity of each pair is shown here. Let's discuss on the characteristic of thermocouple. In terms of sensitivity, the sensitivity of thermocouple is considered small, which show by the range of voltage output that usually just less than 100 millivolts. Therefore, the sensitivity is small. For example, type J is having sensitivity of 0.05 millivolt per degree C. In terms of construction, the thermocouple was constructed by welded two metal together and twisted and sheathed in a protective covering. In terms of temperature range, different types have different temperature range. For example, type J, 150 to 745, type S, up to 1765 degrees C. In terms of time response, it is depend on the size of wire and protective used with the thermocouple. Since the voltage output is small, around millivolt, the signal conditioning for thermocouple is high gain differential amplifier. Then the last one is the characteristic of thermocouple, that thermocouple is affected by electrical noise. Since the voltage are small, a great care must be taken to protect against electrical noise by using shielding, which is the protective covering, twisting extension wire, and ground the foil wrap of the extension wire, and also having a high gain differential amplifier. Here is the reference junction. Nowadays, automatic reference correction is now common in thermocouple system. For example, thermistor or other solid-state temperature sensor are used to measure the temperature reference and provide correction to the thermocouple. As overall, the advantages of the thermocouple, it has rugged construction, inexpensive, simple to use, and extremely wide temperature range, which is around minus 270 degrees Celsius to 2800 degrees Celsius. For the disadvantages, thermocouple has a nonlinearity relationship of temperature and voltage. This diagram shows the curves of thermocouple voltage versus temperature for type J, K, and type S. It shows that the curve has different sensitivity and also non-linearities.